Okay, so we're going to start with solving our one-step equations. What makes it a one-step equation? There's only one thing you have to do to get the variable by itself. Our goal when we are solving our equations is to get the variable by itself. Okay, what I like to do is always put my line through the equals. The reason we put our line through the equals is so whatever you do on one side of the equation, you do that same thing on the other side. So I'm going to draw a line through the equals. Okay? So, I also like to circle my variable, because that's what I'm trying to get all by itself. Okay? Sometimes we struggle. Which way are we moving stuff? My goal is to get the m by itself. So right now we're just looking at the left-hand side. What is on the same side as the m? What kind of 12? Or a plus 12. What's the opposite of a plus 12? Minus 12. So I'm going to subtract 12 on both sides. If I write minus 12 on the left, I have to write minus 12 on the right. When I do 12 minus 12, what happens? They cancel each other out. 12 minus 12 is 0, so I don't need it. So I get m equals, what's 10 minus 12? Negative 2. Do I now have my variable all by itself? Yeah, what's the variable's value? Negative 2. You can check yourself by plugging that negative 2 back in. What's negative 2 plus 12? Or what's 12 minus 2? Does that work? Yes. You always should check yourself, okay? Sometimes, especially on these easier ones, we work really, really fast and we make careless mistakes with like adding and subtracting with negative numbers. Check yourself, okay? So we're going to draw a line through the equals and circle our variable. So I care about what's on the same side as the variable. So looking at that right side, what's on the same side as the variable? A minus 9. What's the opposite of a minus? A plus. So I'm going to add 9 on both sides. What's negative 2 plus 9? 7. What happens with negative 9 plus 9? So I get g equals 7. Do I now have my variable all alone? Yeah. The value of g is 7. I can substitute 7 back in for g. What's 7 minus 9? Negative 2. Does that work? Remember, guys, talking to me makes this go by faster, which gives you more time to do your homework and makes life more enjoyable in here. Does it work? Yes. Okay. When you have a number and a variable glued together, there's no plus or minus sign in between that negative 7 and the y. What operation is that? It's multiplication. So then the opposite is division. So this is negative 7 times y. So what's the opposite of times? Divide. I'm going to do a fraction bar to show division. That's another way to represent division as a fraction bar. What am I trying to move away from the y? The negative 7. So I'm going to divide by negative 7. Negative 7 over negative 7. It's not 0, it's 1. So it's 1y, but do you need a coefficient of 1? No. So it's y equals, what's negative 91 divided by negative 7? 13. Now again, guys, it's a good idea to go back and check yourself. So I'm going to do negative 7 times y, which we just found its y's value to be 13. So negative 7 times 13 is 91. It matches. Okay. Number 4, these are the ones we struggle with the most. Draw your line through the equals and circle your variable. I kind of said it in the last problem. What's that fraction bar represent? Division. So this says a divided by 9. What's the opposite of divide? Multiply. So I'm going to write times 9. I'm not going to put an x to show multiplication. I'm putting a dot, because if we put an x a lot of times we think it's the variable x. So if I write times 9 on the left, what do I need to do on the right? Times 9. This is also where we struggle sometimes. We see 9 times 9 becomes 81. Does this become 81a? Bless you. No, why not? I see some heads shaking no.
Because you multiply the 9 by the 8, not the 9 by the 9.
This says times 9, and then it says divide by 9. Doesn't a times 9 and a divide by 9 cancel each other out? They're opposite operations, inverse operations. So times 9 and divided by 9 cancel each other out. So then I'm left with a equals negative 4 times 9. Negative 36. Again, take the time, guys, and check yourself. I'm not making you write out the check, but use your calculator to check yourself. A, which is negative 36, divided by 9, and it should give me negative 4, which it does. Okay? How do we feel about those? Good? Okay. Now we're moving on to fractions. How many of us hate fractions? If you don't have a calculator, go get one right now, okay? If you don't have a calculator, go get one right now, because I'm going to show you something that my guess is you don't know how to do on the calculator. Okay? And you're going to like it. It's going to help us with fractions. To get rid of the fraction, you multiply by the reciprocal. What is a reciprocal, guys? Flipped fraction. A reciprocal is a flipped fraction. Okay, so this says 2/3 times x. I'm going to draw my line through the equals and circle my x. It says 2/3 times x. The opposite of times is divide. So I would divide both sides by 2/3. But do we know how to divide by fractions? No. So you multiply by the reciprocal, which is your flipped fraction. So instead of dividing by 2/3, I'm going to multiply by 3/2. Multiply by 3/2. Remember, what you do to one side of your equation, you do to the other. You have a 3 on top, 3 on bottom, what happens? They cancel out. You have a 2 on bottom, a 2 on top, what happens? Cancels out. So we have x equals, I'm going to show you all something I didn't show you last class. Let's go to our calculator. We can type in 10 times. Your calculator will actually do a fraction for you, okay? If you do alpha, which is the green button on the left, y equals, which is the top left button, see where it says n over d? That's your fraction, numerator over denominator. So again, how did I get there? Alpha, which is your green button, y equals, and then you hit enter. Notice when I do that, you have a little fraction pops up. Do we like that? Helps us with our fraction operations. So then put in 3/2. Anyone need help with this? You want to know how to put fractions in the calculator, because a lot of us struggle with fractions. Anyone need help? Also, a great thing about it is it fully reduces your fraction. This time we get a whole number, but if it was a fraction, it gives you the fully reduced fraction, so you don't have to worry about reducing it. It's already done for you. Okay? Now, why is it 15? Whole number times the numerator. What's 10 times 3? 30 divided by the denominator. What's 30 divided by 2? 15. That's why it's 15. Okay? You can check yourself. Let's put our 2/3. Again, how do we put the fraction in the calculator? Enter. So 2 over 3, and then you have to arrow to the side to get out of the fraction, times x, which we just calculated to be 15. Does it give me 10? Yeah. Yep. Guys, one thing I want to tell y'all, a lot of times people always tell me, you're so good at the calculator, you're so fast. The reason I am is because I do it a lot. So if I'm telling you to do something on the calculator, please do it with me, because that way you'll get better using the calculator. You'll get faster at using the calculator. Okay? We good? How many of us like that fraction tool? If you don't, then I guess you're a person that doesn't dislike fractions, which I don't, but I'm also your math teacher. Okay, next one. Draw your line through the equals and circle your variable. Okay, what's on the same side as the W? The fraction, the 4/9. Does that say 4/9 plus W, 4/9 minus W, 4/9 times W? Very good. So the opposite of times is divide. But we don't know how to divide with fractions, so we have to multiply by the reciprocal. So I'm going to write times what? 9/4 on both sides. The 9s cancels, the 4s cancels, so we get W equals, let's type this in, -8 times, how do we do the fraction? Alpha y equals enter, 9/4, and we get -18. Good? Do y'all think you can do number 7 on your own? No? We'll do 7 together and then you'll do 8 on your own. Okay, draw your line through the equals and circle your K. What am I going to do to get the K by itself? Multiply by the reciprocal. What's the reciprocal of -6/5? -5/6. The negatives cancel. 5 on top, 5 on bottom, 6 on top, 6 on bottom cancels. So I'm left with K equals. Guys, when you multiply a fraction by its reciprocal, everything cancels out. So that's how you get your 1, in this case 1K. So I'm going to do 12 times negative alpha y equals 5/6. And we get -10. Okay, now y'all try number 8 on your own. Try number 8 on your own. Check yourself once you do number 8. Once you get an answer, check yourself. Guys, I am showing work, so I want to see work on yours as well, okay? Green, white. Oh, do -9 times. Sorry. Do -9 times the fraction. So now we -2. And then arrow to the right takes this one. have to know the difference to get it right. There you go. Okay, so I saw lots of good answers, guys. One thing I did notice is a lot of y'all are thinking when you typed it in the calculator, we did times negative 2 over 1 times negative 2 over 1, which is great. A lot of y'all put a negative with the 2 and the 1. Okay? When you have a negative fraction, when you are working with it, the negative has to go in front of the fraction with the numerator or with the denominator. If you have a negative fraction, you can't put the negative in the numerator and the denominator. Because what's a negative divided by a negative? No longer a negative fraction, right? So you have to have the negative sign with the numerator or with the denominator or out in front, but you can't have it with both. So this is what I saw when I was walking around, and y'all did a great job. Remember, we do not change the operation sign. We're not changing it from a negative 1/2 to a positive 2 over 1. The only time we're changing the sign from positive to negative or negative to positive is when we're undoing our addition and subtraction. Here we're undoing our multiplication, so we're not going to change the sign. So those cancel, and I get n equals positive 18. Okay? Walked around, I saw almost everyone get it right. Good job, y'all. And there might have been small mistakes of signs. Okay, but y'all did really well. How do we feel with our one steps? This is what y'all did last year, right? For the most part? You should have. Okay. Okay, now we're going to go on to two-step. Two-step, it's really not any harder. You just now have to do 2 things instead of only 1. Okay, the catch is you have to make sure you do them in the correct order. The order does matter. You always have to undo your addition and subtraction first. Get rid of the constant first. You have to get rid of the constant first. Then we are going to get rid of the coefficient. If you get rid of the coefficient before you get rid of the constant, you're going to get the wrong answer. Okay, guys, we are all awake, right? We're all awake, right? Tap her for me. Sit up, sweetie. Okay, sit up. Okay, same thing we did before. We're going to draw a line through the equals, and we're going to circle our variable, because my goal is to get the variable by itself. Notice when I'm circling the variable, I'm not circling the coefficient with it. I'm just circling the variable. Okay? So, on that left-hand side, I have a 6 and an 8. Which one's my constant? A constant's a number without the variable. Remember, the word co means with, so your coefficient is the one with the variable. So 6 is glued to the variable, that's your coefficient, so I'm going to get rid of my 8 first. That's a plus 8, that's your constant. How do you get rid of a plus 8? What's 8 minus 8? Drop down your 6x equals, what's 50 minus 8? 42, good job. Keep your x circled. X is not by itself, there's still something with it. What's with the x?
6.
The 6, what does that say? 6 what x? Times x. So what's the opposite of times? So I'm going to do my fraction bar to show division. Divide both sides by 6. 6 over 6. Cancel, and I get x equals 7. Just like on the top, we can check this, guys. 6 times 7 plus 8. 6 times the x value, which we just found to be 7, plus 8. What should it give me? 50. Did it? Yes. Check yourself. Okay? We good? So you always undo your adding and subtracting, always undo your constant before your coefficient. Draw your line through the equals, circle your variable. Looking at the left side, the variable side, which one of those is your constant? The minus 5. How do you undo a minus 5? Plus 5. So we're going to add 5 on both sides. So negative 5 plus 5. And I get 2n equals 16. Good job. Keep your n circled because n is still not by itself. What am I going to do to get that 2 away from it? Divide by 2. Remember, what you do to one side, you have to do to the other. Okay? So I get n equals 8. Good? Check yourself. 2 times 8 minus 5 gives me 11. Guys, on your test, which is not until September 1st, or y'all's actually is August 31st, can you check almost all these answers? Yes, are we doing that right now? Do you think you should do that? Yes, don't you want to know if you got the right answer or not? I would, because if you don't have the right answer, I would retry the problem. Okay? Okay, what makes 11 different? The variable is now on the right side. We're still following the same process, but now we're looking at the right side because that's where the variable is. Okay? So what am I going to do to get the variable by itself? Which one's the constant, the one not attached to the variable? How do you get rid of a plus 9? What's 13 minus 9?
4.
The 9 minus 9 cancel each other out. Keep your k circled. What do I do next?
Subtract -4. 5 negative.
There you go. That says -4 times k, so the opposite of times is divide. Divide both sides by -4. And I get k equals -1. Be careful, these don't cancel out. Okay, 4 divided by -4 gives you -1. Again, check yourself. -4 times -1 plus 9 gives me 13. Okay? Okay, I want you all to try number 12 on your own.
Process. Get math tables. Three's negative. 7's positive. How do you get a positive 7 from the left to right? Now, subtract 7.
Okay, let's look at this, guys. Some of us were struggling on this one because that 7's positive, the 3 is negative. The 7's not negative. So remember, we always get rid of our constants, which are the ones not glued to the variable, first. The 7 is not glued to the variable. That's your constant. The 7 is a positive 7. So we need to do what? Subtract 7. Okay, these are the ones we really struggle on because we see that minus. That minus is pertaining to the 3. The 3 is negative. The 7 is not negative. So 7 minus 7 cancels each other out. When I drop down my 3y, there's a minus in front of it, or a negative. Okay, keep your y circled. What do I do to get the y by itself? Divide both sides by negative 3. Very good. So we get y equals, take the pass, sir. Okay. How do we feel? Okay. Luckily, we're doing more. Okay, we're probably not going to do all these. We're only going to do the odds. Okay. So let's do number 13. Draw your line through the equals. Circle your variable. What number is on that side with the x that's not glued to the x? The negative 7. How do you get rid of a minus 7? Plus 7. We add or subtract our constants. Negative 7 plus 7 goes away, and I have x over 2 equals 16. Keep your x circled because x is still not alone. What's on the same side as that x? The 2. What's that fraction bar represent? What's the opposite of divide by 2? Multiply both sides by 2. Times 2 and divide by 2 cancel each other, and I get x equals 32. You can check yourself. 32 divided by 2 minus 7 is 9. Good? Okay, let's look at 15. Draw your line through the equals and circle your variable. Okay. What's on the same side as the x but not glued to it? How do I get rid of a plus 22? Minus 22. So 22 minus 22 cancels out. And I get 3/5 x equals 6. Keep your x circled because it's not alone. Okay. Now I have a fraction times x. How do you get rid of a fraction? Multiply by the reciprocal. So multiply by 5/3. The 5's cancels, the 3's cancel, and I get x equals, and then you can type this in your calculator. Again, how do we do that fraction?
Alpha y
And we get, do it on your calculator, guys. What do we get? 10. Good? No? Somebody say no? I'm hearing things. Okay, we're not going to do 17, let's do 18. Draw your line through the equals, circle your variable. What do we think we need to do first? Notice again, the 9 is positive, the 1/2 is negative. So how do you get rid of a positive 9? So what's 15 minus 9? 6 equals negative 1/2 x. Circle the x. What do I do next? Multiply by the reciprocal. What's the reciprocal of negative 1/2? Negative 2 over 1. So the negative 2 over 1 cancels with the 1 over 2. Multiply this side by negative 2 over 1. I want you all to type this in the calculator yourself.
Negative 12.
What is it?
Negative 12%.
Negative 12. Great job. How do we feel about these? Okay. What makes these look different?
There's not just a variable on top of the fraction.
It's not just a variable on top of the fraction. There's now a big fraction. There's 2 terms over the denominator. 2 terms over the denominator. 2 terms. 2 terms. Anytime you have a big fraction like this, you have to get rid of the denominator first. Okay? So, we're going to draw our line through the equals, and the reason why we have to get rid of the denominator first is because I can't just subtract 11 because this isn't really 11. It's 11 over 8. Okay, so I need to get rid of that over 8 because both my x and my 11 are being divided by 8. So how do I get rid of a divide by 8? Multiply by 8. So the times 8 and the divide by 8 cancel each other out. And I get x plus 11 equals negative 24. Should be circling my x, sorry. What am I going to do now to get x by itself? Minus 11, very good. That is a constant. We add and subtract constants. So I get x equals? Very good. Now, what I really like about these calculators, guys, if you do alpha y equals enter, you can put negative 35 plus 11 all in the numerator over 8. Okay? You can put in a big fraction like that. And we get negative 3. Okay? Let's look at the next one. What am I going to do first? Times both sides by negative 2. Good job. We would need to get rid of the denominator because we have a big fraction. We have multiple terms in the numerator. So the times negative 2 and divide by negative 2 cancel. And I have my n minus 5 equals 14. Keep your n circled. What do I do next? Add 5. And I get n equals 19. Good? Guys, I will say, I know today some of us are doing really well and we remember this from last year and we feel like we don't need to show all your work. I promise you, we are doing this for 5 more days. The problems are going to get harder. So make sure you get in the habit now of showing all your work so whenever the problems do get harder, you don't get confused. Okay? Show all your work for me. Look at number 21. Draw your line through the equals, circle your variable. What are we going to do? Rid of the big denominator, which is negative 6 times negative 6. What's negative 6 times 1? What happens with the negative 6? Divide by negative 6. They cancel. A times negative 6 and a divide by negative 6 cancel. So I have my a minus 13. Keep your a circled. What do I do next? Add 13 plus 13. So it's negative 6 plus 13, or 13 minus 6. 7 equals a. Do we feel like we can do the last one on our own? I do. Okay, try 22 on your own. Okay, let's flip, guys. I saw lots of good things. Draw your line through the equals, circle your W. Times 9, and I get 36 equals W plus 8. Keep your W circled. Minus 8, and I get W equals 28. So lots of good stuff. Okay, we good? Okay, now we are moving on to solving inequalities. I will tell you the great thing about solving inequalities, same as solving equations, okay? First, we need to know how to graph our inequalities, okay? So, you are going to use an open circle for less than or greater than signs. You are going to use a closed circle for less than or equal to, greater than or equal to. Do we know those signs, guys? Okay. These are less than. So the way I try to remember it, okay, if it's like this, if I open my fingers, it makes an L for less than. Okay? So if I have my less than sign, which looks like this, if I straighten out my fingers, there's an L. What's L stand for? Less than. If I do my greater than sign, which is this one, if I straighten it out, that's not an L. Okay, so that's not less than, that's greater than. Okay? Then these lines under it mean equal to. So these are less than and greater than. These are less than or equal to and greater than or equal to. Okay? One thing we want to make a note of, over to the side, always have the variable on the left when graphing. If the variable is on the right, flip it. Okay, if the variable is on the right, flip it. The variable must be on the left when graphing. Okay, otherwise we're going to get it wrong. We're going to make a silly mistake. Okay, so the way we do these. Do I have an open or closed circle? Do you see the equal to under the line? No, there's no equal to under that inequality sign. So it's going to be an open circle on 3. So go to 3 and put an open circle there. Okay. Now, if I read this, it says x, is that a less than or a greater than? X is less than 3. So which side of your number line is less than 3? The left side. Left is less. Okay, right is greater, left is less. So I'm going to shade this left side or draw an arrow, a line, with an arrow at the end to show those are all my possible solutions. The difference between your inequalities and your equations Equations, we get one solution. Inequalities, there's an infinite number of solutions. This says x is less than 3. Tell me a number less than 3. 2. Tell me another number.
Negative 100,000.
-100,000. Tell me another number.
0.
-8. 0. All of these numbers are less than 0. Sorry, less than 3. Okay? So that's why we shade on our number line to represent all possible solutions. Okay? So looking over here, do I have an open or closed dot on -1? Open. You don't see the line under it, so don't fill it in. So I have an open dot at -1. Okay? That's always your first step. Which way am I going to shade? To the right, because this says x is greater. Greater numbers are to the right. Why do you think it's important to put this arrow at the end, guys? Shows there's more options. 8 is not the last number that's greater than -1. There's a ton more numbers greater than -1. That's why we have to keep going. Okay? Okay. Open or closed dot on 7. Okay, so my kind of saying for this is if you see the added ink under the inequality sign, what I mean by that, you see the added line under the inequality sign, fill it in. Use extra ink to make your circle. You're going to fill in your circle. So I'm going to do a closed dot on 7. Now which way am I going to shade? To the right, because this says x is greater than or equal to 7. When we have the or equal to, greater than or equal to, is 7 a solution? Yeah, because it can equal 7. Up here, whenever it said x is less than 3, is 3 a solution? No, it has to be purely less than 3. It can't be 3. There's no equal to 3. So that's what the open circle denotes. The open circle means it cannot equal. The closed circle means that, yes, that is included in my solution set. Okay? Open or closed dot on -5? Do you see the added ink? Do you see the equal to line under the inequality? So it's a closed dot on -5. And which way am I going to shade? To the left, because it says less. Guys, why did I say always have the variable on the left? If my variable's on the left, which way is this inequality sign pointing? Where's the point? To the left. Which way did I shade? Which way is the inequality sign pointing? To the right. Which way did I shade? To the right. Which way is it pointing? To the right. Which way did I shade? To the right. Which way is it pointing? And I shaded to the left. So your inequality sign is pointing the way you shade only if your variable is on the left side. Okay? We good with that? Okay, now we're going to look at the number line and we're going to write the inequality. So we're doing the same thing, but backwards. Okay? So, let's start with our variable. I'm just going to use x. Leave space for your inequality. What number is the dot? -2. So leave space for your inequality and then put -2. Which way is the shading? To the left or to the right? To the left. So should it be a less than or greater than? Less than. So put a less than sign. Should I put an equal to under it?
No.
Why not?
It's open.
It's an open one, meaning -2 is not a solution. Okay? So there's my answer. Good? Okay, next one. Can we use a different variable other than x? Sure, let's use a. And what number is my dot on? 4. Leave space for your inequality. Which way is this one shaded? To the right. Is it an open or closed dot? So what should I do? Put the equal to under the inequality. Okay, next one. Tell me a variable we want to use. Y. And what number is the dot on?
0.
Okay. Which way is it shaded? To the left, so the less than or greater than? Because remember, less is left. Do I put the equal to under my inequality sign?
Yes.
Yes. Okay, y'all do the last one on your own. Mm-mm. Does not matter, you can use any variable. Okay, what variable did we choose? W. What number is the dot on? -3. Which way are we shaded?
Right.
So is it a greater or less? Greater. Again, the arrow's pointing to the right, we shaded to the right. Should I have an equal to under it? No. Done. Are we okay with how we graph on a number line? Okay, now we're going to actually solve our inequalities. Like I said, the good thing is these solvings are exactly like solving equations, it's just we have to graph on our number line solution set, okay? Bless you. There is one special rule when we're doing inequalities. You must flip the inequality symbol when you multiply or divide by a negative number. Now, biggest thing, people think anytime there's a negative, anytime I multiply or divide, we're flipping inequality signs. That is not the case. You only flip the inequality sign when you multiply or divide both sides of your inequality by a negative number. Okay? What does it mean to flip the inequality sign? If it's a greater than, it becomes a less than. If it's a less than, it becomes a greater than. You literally just flip it. Okay? So, same process we had before. Draw your line through the inequality, circle your variable. What am I going to get rid of first? The +2. How do you get rid of a +2? -2 on both sides. 3x is less than -6. Keep your variable circled. What do we do next?
Get rid of the 3.
How?
Divide by 3.
Divide both sides by 3. Are we flipping the sign? There's a negative, though. What are we dividing both sides by?
3.
A +3. Even though this is a -6, we're dividing both sides by a +3. So do we need to flip the inequality sign if we're dividing by positives? No. So we get x is less than -2. Okay, when we make our number line, always put that number in the middle. So -2 goes in the middle. Then -1, 0, 1, -3, -4, -5. We struggle sometimes numbering our negative number lines. Remember, negatives are opposite of positives. Okay? Always put the number that we get for our solution in the middle of your number line, and then go in numerical order to the right. So one bigger each time, and then one smaller each time to the left. Okay? Open or close dot on -2. Open. There's no equal to. -2 is not a solution. Which way am I shading?
Left.
To the left. Good? Next one, draw your line through the inequality and circle your variable. What am I going to do?
Get rid of the 2.
How do you get rid of the +2? -2. Very good. Drop down your x over 6 is greater than -3. Keep your x circled. What do I do next? Multiply by 6. Very good. Remember, 6 times 6, that's not what this is saying. This does not become 36. This says times 6 and divide by 6. They undo each other. We multiplied. Do we flip the inequality sign? No. Why? We're not multiplying by a negative. We're multiplying by a +6. Okay, so -18 goes in the middle. -17, -16, -15. Open or close dot on -18. Is -18 included in my solution? Can it equal -18? No, so can I close the circle? No, it's an open circle on negative 18. And which way do I shade?
Right.
To the right, because it says greater. The arrow's pointing to the right. Are we seeing how this is essentially the same as solving our equations, guys?
Yes.
Are we feeling pretty confident with these?
Yes.
Okay, so we're going to go on to some now where we might need to flip. Okay, so let's look at number 11. Draw your line through the inequality and circle your x. What am I going to do first? Minus 8. We're almost done with our notes, guys. Thank y'all for being hardworking and patient today. Positive 8 minus 8? 0, so drop down your negative 7. X is less than or equal to? Negative 7. Keep your x circled. Very good. What do I do next? Divide by negative 7. Whoa. What are we doing on both sides, guys? Dividing by, so what do we need to do? Flip the sign. Instead of being a less than or equal to, it's now a greater than or equal to. What's a negative 7 over a negative 7? Positive 1. So let's write a little note over to the side that we must flip. So we are going to put 1 in the middle, so 1, 2, 3, 4, 0, negative 1, negative 2. Are we okay with how I'm numbering my number line? After you number it, go back and look. Negative 2, negative 1, 0, 1, 2, 3, 4. Is that in numerical order? Is that how you would logically count? Okay. Open or close dot on 1? Closed. And which way am I shading?
Right.
To the right. Guys, one thing you could do to check yourself. Tell me any number in that shaded region other than 1. Tell me a number bigger than 1. 3. Okay, so let's try 3. Negative 7 times 3 plus 8. So I picked any value for x that's in the shaded region. If I hit enter, it should be less than or equal to 1. Is this number smaller than 1? Yeah, that means I shaded the right way. Okay? Let's say I plugged in a value in for x and it said like 20. And then I got 20 is less than 1. Would that be true? That would mean I shaded the wrong way. Okay, so there is a way, just like solving your equations, that you can check your inequalities. Okay? Okay, let's do 12. Line through your inequality and circle your x. What are we going to do? Add 5. Negative 5 plus 5. Gone. And I have x over negative 8. Do I flip the sign? Nope. Less than 3. Keep your x circled. What do I do next? Times negative 8. Whoa, what happened? Flip the sign because I multiplied both sides by a negative. So I get x is greater than negative 24. Negative 24 goes in the middle, and let's write a little note to ourselves that we did flip. Okay. So negative 23, negative 22, negative 21, negative 25, negative 26, negative 27. Open or close dot on negative 24. And which way am I shading? Okay. How are we feeling, guys? Do we think graphing our inequalities or doing inequalities is pretty similar to our equations? Are we ready to do just one more? Okay. That way then you'll have time in class to do your homework, and if you're still struggling, I can help you. Okay. So let's look at number 20. This one was the one that was kind of different, right? Because now I have a big fraction. Draw your line through the inequality and circle x. What am I going to do? Times negative 2 on both sides. What happens when you multiply by a negative, guys? Well, you flip the sign. Okay? So the time, negative 2, and divide by negative 2 cancel. So I'm going to drop down my x plus 11. That's negative 2 times negative 2. Positive 4. Keep your x circled. How do I get rid of a positive 4? Sorry, how do I get rid of my plus 11? Minus 11. So I get x is greater than negative 7. Very good. Open or close dot on negative 7. Open. Which way am I shading? To the right. Good? Okay, so if you did not finish your homework, which there were maybe like 5 of us that did not finish our day 1 homework, do that first, okay? Then we need to do our day 2 homework. So y'all can all go get Chromebooks. When you're over here,